Alright, on number 1 here, given this statement, x to the power of n times x to the power of b equals x to the power of 21. Find two numbers for n and b that satisfy the equation. Well, based on the rules we've discussed in class, this is one of those. We've got the same base, but we have different exponents. And some of you remember from this rule, what we do here is if we were to expand this, we would just take the exponents and just add them. And this has to equal x to the power of 21. So in other words, n plus b has to equal 21. So you get to choose whatever two numbers you want to use. Maybe some of you want n to be 1 and b to be 20. Some of you may prefer to use 5 and 16. As long as those two numbers add up to 21, you'll be fine. Now, it is possible on the test, you may see something like they require you to use a negative. So if you have a negative 5, that would make this be 26. Okay. So based on that rule, we just need those two numbers to add up to 21. And those two do, as well as those other ones that we covered. So number 2 here, we're going to simplify this, but we're going to use positive exponents only. And that's not a problem because this one only has positive exponents. Now if we wanted to expand this, you would have 3 of these y to the 11th. And since this is all multiplication anyways, you just take the exponents and add them, and you'd get y to the 33rd. The other way some of you may know how to do this is just take 11 times the 3 times 3, and you'd get the same answer here anyways. Alright, on this problem, so some of you may choose to distribute the 9 first, others may choose to work inside the parentheses first. It's not going to matter. You get to choose which method you use. Now, if we stick with the order of operations, we'll want to use or work just inside the parentheses first. Now that 3 inside the parentheses, there's nothing we can do with it. We can't divide it by anything or multiply it by anything, so we're just going to keep it there. Now on the other hand, we have this a, and we have the 6 in the numerator, and the denominator is 15, so if we subtract these, we get a to the power of negative 9. Now if we keep it like this, the a will be in the numerator, and the b will work the same way if it comes out negative, but that numerator exponent is 13, and we'll subtract that from that phantom 1 exponent, and we'll get b to the power of 12. So that's one way to do it without using this denominator stuff. It's still be in parentheses. But we will need the denominator anyways, since the power of a is negative. So that will move to the bottom there. And in the numerator we get that 3b to the 12th, and then we got that power of 9. So, was described in class, we can distribute this 9 to all of the exponents. By the way, that exponent of 3 is 1. And that would give us 3 to the power of 9 times b to the power of 108 over a to the power of 81. Now if you want to take 3 to the power of 9 and find out what that is, that's fine. I don't know what it is. I guess I can find out. 3 to the power of 9, I'm using a calculator. I get 19,683. If you wanted to write that in place of 3 to the power of 9, that's fine. That's up to you. Okay? But both of them are accepted. Alright, for number 4, what I might do here is just kind of draw some lines in this just so we can separate this stuff. So I've got the x's kind of in a row there, and the negative 12 to the negative 2, that's going to have to switch. So when I rewrite this, I know that this negative 12 to the power of 2 ought to be in the denominator. Well, let's look at these x's. Here I've got x to the negative 7 in the numerator, and I'll have to subtract 5 from the exponent in the denominator, which gives me x to the power of negative 12. Now that would be in the numerator, but I want this to be positive, so I'm going to change the sign of that exponent and put that x in the denominator. I'll do the same thing with the y's if it's necessary, but let's look. We got y to the 18th, that's the numerator exponent, minus, because this is division, but that's a negative 12. So what I'm going to end up doing anyways is adding those, and what I'll end up with is y to the power of 30. And this would be my answer. Alright, number 5, some of you guys are going to look at this and panic, but once you see that 0, hopefully it's not too bad. This is a negative, and we would have a 1. So the answer is actually just negative 1 here. Alright, looking at 6, well, the first thing we're going to want to do is distribute that 2 in there so that we've changed the powers inside the parentheses. That x to the power of n is going to remain, but we've got to distribute this 2. So that would give us 3 to the power of 8 and x to the power of negative 2n. Now we could rearrange these, so we have x to the power of n, x to the power of negative 2n, and 3 to the power of 8. All this does is it helps us to see this x to the power of n times x to the power of negative 2n. And we can see very clearly that's the product rule there. So we have common base of x, so of x plus a negative 2n, which really is just a minus 2n there. So we have x to the power of negative n, and that 3 to the power of 8 stays. But since we don't want any negative exponents like we have with the power of x, let's go ahead and move that into the denominator, and 3 to the power of 8 stays with a positive 8 power. Alright, number 7. This one is kind of the same idea. We just have some big numbers. Don't let those big numbers be a problem, because you can do all those calculations in a calculator. And also, please bring a calculator, so it's not a problem, alright? Alright, so we can rearrange all of this because it's just multiplication between all of these. So we could say we have 24 times 10 times x to the 13th times x to the 81 times y to the 25 times y squared. So all I've done is rearrange this so that like terms are closer to each other. It may be easier for you to work that way. I don't know. That's up to you. Then we got 24 times 10 is 240. And we've got the x's, x to the 13 plus 81. And the y's, y to the 25th plus 2. So this allows me to finish this off. We got 240 x to the power of 94, y to the power of 27. All right, for number 8, this is subtraction between these two polynomials. So what we'll need to do is change these signs. We'll change this to plus, but if we do that, we've got to change the signs of all of the terms in the parentheses here. And that's fine, so we can rewrite this now. 11x to the 5th, y squared minus 20x squared plus 10z. Notice that expression on the left did not change. And now we've got this plus 19x to the 5th, y squared minus 5x squared plus 24z's. Now I'm just showing you guys one way to do this, but there are many ways. Okay, so you get to choose. You get to choose whichever method you want to use. Now it's important for us to identify like terms. So what we need is to have the same variables in a term, and if the variables have exponents, they have to have the same exponents. For example, if we were to look at this 11x to the 5th y squared, all we've got to really do is look at the variables x to the 5th and y squared like this, okay? Are there any other terms that have x to the 5th and y squared? Well, negative 20x squared does not. 10z does not. But when we get to this term, 19x to the 5th y squared, that one does have the same variables, and they have the same exponents, respectively. Moving along, we can see that negative 5x squared is not like terms, and neither is this 24z. Now what happens here is that the variables and their exponents aren't affected because we're just adding these. And what we'll do is we'll take 11 plus that 19 to get 30 as our coefficient. Now don't forget, each term is going to take the operation to its left as its sign. So for example, this 11x to the 5th y squared, there is no operation to its left, so it's fine. We know it's positive. But this 20x squared, we would say that it's a negative 20x squared because of that minus sign. This 10z would be positive because of the plus sign. And this negative 5x squared is negative because of the minus sign. Alright, moving forward, let's look at the x squareds. Well, there's a match. And so again, you're going to keep the variable and its exponent alone. You're going to leave it alone. But the coefficient is going to change. Negative 20 minus 5 would give you a negative 25x squared. Then we've got this 10z and this 24z. So again, we've got a z. And notice for these first two terms, that was a negative 25. So it really comes out to minus 25x squared because the negative would force you to subtract if we were to add it. Alright, 10z plus 24z would give us a positive 34z's. And that's all there is to this. We're just looking to simplify these expressions. Alright, well, how about number 9? I'm going to go ahead and do this one a little bit different. So if I look at this first expression, 17x squared plus minus x plus 103. I can stack these on top of each other, and usually you want to stack these so that you have like terms with each other or stacked on top of each other. So in other words, the 18x squared would be right here in the same column as 17x squared plus a 4x. Don't forget that that's a 1x there, okay? And then plus the 57, so we have constants lined up with each other, and this is addition. So we can just add each term, 17x squared plus 18x squared. So again, don't forget that it's not messing with the x squared or the x, okay? That will give us a 35x squared, positive. Negative 1x plus 4x would give us a positive 3x. And 103 plus 57 would be a positive 160. And that's it. That is the final answer for this problem. And there we go. Now please don't forget, you can pause this video anytime you want. You can replay it, rewind it. I think you can even control the speed. So if I am going too fast, feel free to slow it down or pause once in a while. Or you can start the problem over and watch it as many times as you want. Okay? Alright, number 10, neglecting air resistance. The height of an object dropped from a spaceship is given by this polynomial function. P of t equals negative 16t squared plus 12,345 after t seconds. Find the height of the object when t equals 21 seconds. Alright, well that sounds good. So let's look at the original expression here, the equation or function. So it gives us P of t equals negative 16t squared plus 12,345. But we're going to replace the t now with 21 seconds. Which is what we're trying to find here. And yeah, I'm going to use a calculator to figure this out. 21 squared, that's going to give us 441. And everything else is the same here. Then we'll have to multiply negative 16 times 441. And that gives us a negative 7,056 plus this 12,345. And so P of t, the height, looks like it's going to be 5,289 feet. Alright, so again, all we did was replace the t with 21 and then solved the function. You can call it equation if you want. Alright, when multiplying binomials, some people prefer to use the area model, which I'm going to show you guys here once again. I really like the area model, but if we do the area model, we need to focus just on these first two expressions. So, otherwise it becomes a volume model. So if I say that this is y, and this would be minus 4. In other words, the length of that side is y minus 4. which is our first expression there, y minus 4. So the other expression would be y and a plus 4, because that would be the length of the side of this rectangle. Now all we're trying to do here now is to figure out the area of each rectangle inside each smaller rectangle of the big one. So to find the area of this upper left rectangle, it's just y times y. That's y squared. To figure out the length of this rectangle, we'll multiply this y by 4, and we'll get 4y. If we look now at this rectangle, the area is a negative 4y, and this rectangle here will give us negative 16. So if we were to write that out, we would have y squared plus 4y minus 4y minus 16. All we're doing is adding the areas together to find the total area. And some of you can see, if we combine like terms, we'll still have the y squared, but these two will cancel out and we'll have minus 16. So that allows us now to look at two expressions once again. Two different expressions here. Get this out of the way. Alright, so that gave us y squared minus 16. And we'll multiply it now by y squared minus 25. Well, we can use an area model between these as well. And again, I don't know if this is better for you or worse, but I like to use the area model. And we'll have y squared, and that's a negative 16. And this side will be y squared, and that's a negative 25. Now to figure these out, we're just going to multiply them. So we have y to the 4th, negative 25y squared, negative 16y squared, and negative 25 times a negative 16. Well, that's actually a positive 400. Now when we go to add all these together, should be able to figure that answer out. So we got y to the 4th, minus 25y squared, minus 16y squared plus 400. And then just combining these two like terms, we got y to the 4th minus 41y squared plus 400. And this is our answer right here. Let's take a look at the whole problem just so we can see that all together. Alright, there's your work. So notice again, once we got y squared minus 16, which replaced these two expressions, we were able to make a new area model with that. Alright, well not everyone likes that area model stuff, so I'm going to go ahead and use the FOIL technique on this. Except for there's 3 terms. That's not a big deal. Let's go ahead and rewrite this, but expand this. We got 3 minus. I'm also going to just write this so that we don't have to worry about the parentheses. Okay, so I just distributed that minus or negative. And this is multiplied by the same thing because it's just squared. Alright, so let's look. We've got to distribute this 3 into this other set of parentheses first. So the first term we would have 9 minus 15x minus 6y. Next, again, we're going to look at this as a negative 5x. We'll distribute that into the parentheses, and we would have a negative 15x plus 25x plus 10xy. Looks like I'm going to need a little bit more space there. That's fine. And finally, we've got this negative 2y. Distribute that in, and we'd get a negative 6y plus 10xy plus 4y squared. And I just realized, and I apologize for this, that would be a positive 25x squared. So if you noticed that, thank you. If you didn't, well, I made the mistake too, so please don't hold it against me. From here, all we're doing is looking for like terms to combine, and once we've simplified this, we'll be done. So if we look at 9, are there any other constants to go with 9? No, there's not. So we know 9 is going to be alone. Let's go and look at this negative 15x. Are there any other x's by themselves? Yes, there is. There's this one. And that's a positive 9. So that becomes a negative 30x. What about this negative 6y? Well, yes, there's another negative 6y. So that gives us a negative 12y. How about this 25x squared? No. There's no other like terms with it. That's a positive 10xy, and we got a positive 10xy there. That's a positive 20xy. And finally, we've got that 4y squared. And as it turns out, this is our final answer on this. We were able to simplify this completely. Alright, on number 13, I am going to use an area model again. I hope you guys find it helpful. So I'm going to make this a longer rectangle this time, because I'm going to have to split this one up into 3 parts because there's 3 terms on that second expression. But the second one will be fine like this. This here would be 2x squared and 7. It doesn't matter where you list these, it's all very arbitrary and abstract. This is our 2x squared, a negative 9x, and a positive 8. Multiplying these all together, we'll get 4x to the 4th, negative 18x to the 3rd, 16x squared, 14x squared, negative 63x, and 56. So then we just need to write an expression adding all these together. So we got 4x to the 4th minus 18x. That's a positive 16x squared plus 14x squared minus 63x plus 56. If we look to combine like terms, there's no other terms with 4x to the 4th. We can combine negative 18x with this negative 63x, giving us a negative 81x. And we can also combine these x squareds. So that's a positive 30x squared. And finally, that positive 56 doesn't have anything to combine with. This is our final answer. Right here. Alright, let's look to factor these out. We can see that there's a y squared in each of the terms. So we know we can factor out a y squared. They're in common for each of these. But not only that, but each of the numbers in each term is divisible by 3. So what that would do is it would leave us with an 8x squared here minus 14x plus 3. Now what we need to do is look at these factors of 3, which would be 1 and 3. We may need negatives on this one. And we can look at factors of 8, 1 and 8, and 2 and 4. Now when we factor these polynomials, yes, there may be some experimenting that goes on. If you do, that's okay. But some of you may look and see if we multiply these factors by these ones, then when we add those together, we should get this negative 14. And yes, there will be these x's here. So in other words, let's look at, for example, because you got to look and check some of this stuff. I'll do the wrong one first just so you guys can see what will happen. So let's take 1 and 8 and 1 and 3. So if I need to multiply the 1 by one of these other two factors, I can multiply it by 1. So that would give me a new factor of 1. If I take the 8 and multiply it by the 3, I'll get 24. If I add these together, it does not equal negative 14, which is what we need right here. Okay? So let's look at a different set that we can combine. Let's look at 2 and 4 and negative 1 and 3. I'm going to do another wrong one just so you guys can see what happens, and it's okay to do it wrong. You just may have to try this a few times. Let's look at 4 multiplied by negative 1. That gives me a negative 4. And now I must multiply the 2 and negative 3, which gives me a negative 6. If I combine these two, I'll get negative 10, which is not that negative 14. Some of you know already what to do, and that's fine. Let's go and look at these numbers again. So we may have to retry these, just regroup the numbers. So let's look at 2 times negative 1. That gives me a negative 2. And then 4 and negative 3. Now that gives me a negative 12. Well, if we combine these, we get this negative 14. And that's what we wanted in the first place. That matches that middle number. So what does that mean? Well, we did 2 times negative 1. And we did 4 times negative 3. And we found this kind of tells us where to put these factors, all right? So we know that the 2 and the 4, since they came from this coefficient of x, 8 here, they've got to go in front of the x's in the parentheses. In other words, they're the coefficients of this other set of parentheses. That's the factored set of parentheses. Now look on this one, since it was 2 times this negative 1, that means the negative 1 needs to go in the other set of parentheses from the 2. Likewise, this negative 3 will have to go in the opposite set of parentheses from the 4. That way they'll have to be multiplied by each other. This allows us to check our work here. So if we were to multiply these two binomials, you'd have 2x times 4x, which is 8x squared. 2x times negative 1 is a negative 2x. Negative 3 times 4x is negative 12x. And negative 3 times negative 1 is a positive 3. So you can see it's already looking very much like the expression we started with up there. And this would give us 3y squared. And we have 8x squared minus 14x plus 3. So this is just a way to check it. Our actual answer is this expression right here. This is factored out completely, and it's good. Alright, 15 is going to work a lot the same way, except for this is more than a trinomial. It's got 4 terms. So what we're going to have to do is split this up. Let's first look at the left side, then we'll look at the right side. So what could we factor out of that left side? And usually this will come out pretty nice. We can factor out an x squared, leaves us with x plus 7. Now on the right side we could factor out a negative 4, which leaves us with an x plus 7. So you see this x plus 7 stuff is in both of these terms. So in other words, we can factor that out from these, giving us an x plus 7. And you'd have these factors multiplied by each other as well. Or in other words, when we factored out that x plus 7, that's all that was left over, okay? Now some of you remember from the special rule stuff, this x squared minus 4, we can split that up into 2 separate binomials. We got x minus 4, I'm sorry, not 4. Take that back. That's the square root of 4, which is 2, and x plus 2 as well. Then we also have that x plus 7, and there's our answer for this one, okay? So don't stop at that x squared minus 4. If you stop at this step, you're going to lose some points on the test. We don't want you to lose points. You'll want to check those special conditions, those special binomials and trinomials, in order to know how to factor that completely. Alright, number 16, we got to factor this by substitution. So in other words, we're going to replace this x plus 1 stuff with some variable that we get to choose. Let's choose an a, for example. And this will give us a new expression, 3a squared minus 7a minus 20. So again, all I've done is replaced x plus 1 with this a stuff. Alright. From here, it's we've got to multiply the 3 and the 20 there. So we got to take, in other words, the leading coefficient and multiply it by the constant. 3 times 20 is 60. Now if we split this up and look at factor pairs for 60, what we want to do is figure out, and we would want to figure out which pair of factors, which factor pairs would add up to negative 7. What that's going to do is it's going to allow us to split up that negative 7a so that we can factor by grouping. So 60 would split up, of course, 1 and 60, 2 and 30. None of these are close enough yet. All right, let's look at 3 and 20. Again, we're not very close here. Let's continue this. We've got 4 and 15, 5 and 12. Well, we know we can work with 5 and 12. Let's see if there's anything else. We got 6 and 10, and I believe that's it. Okay. So yeah, we can look at that 5 and 12 there. Now, since if we look up here, this was a negative 20. This would actually be considered a negative 60, which means that one of the two factors needs to be a negative. In addition to that, when we add them together, it needs to be negative 7. So when we split it up, so that when we add these, we'll get negative 7. That means that 12 has to be a negative. 5 minus 12 would give us negative 7. So we would have this 5a and this negative 12a, but we'd still have that 3a squared. That's a positive 5a minus 20. All right, so when we look at these, we're just looking at, for example, 3a squared plus 5a. I guess it's probably better to use a line to split these up. And we can factor out an a from 3a squared plus 5a. And that would leave us with 3a plus 5. And negative 12a minus 20, we can factor out a negative, looks like a 4. That would give us now a positive 3a plus 5. And continuing in this way, all we got to do is split these two up. If we look at these two terms, let me give us some space here real quick. All right. So from these two terms, we can factor out a 3a plus 5. So let's do that. 3a plus 5, we're going to factor that out. And would be left with the a and the negative 4. Now you may be tempted to stop there, but that's not where we need to end this. Because if we look back at this problem, a is actually x plus 1. Which means we'll have a little work to do inside the parentheses as well. Let's take a look. Alright, so taking into account that a is x plus 1, let's go and write our equation here, but now we got x plus 1. Hope you don't mind me using different colors, just to emphasize that we're replacing a. Now what we can do is work inside the parentheses, so 3x plus 3 right here, and that's a plus 5. And then in this case, we pretty much don't even need that set of parentheses. It's not doing us any good. So it would end up with an x minus 3. Well, combining like terms here, we'd get 3x plus 8. And this would be x minus 3, and we're done. So ultimately, this is actually our final answer. This one right here. All right, 17 will work the same way. Since we have a coefficient to x squared, or a leading coefficient of 14, we'll have to multiply the 3 and 14. 3 times 14, and this would give us 42. Now we'll need to split up this 42, okay? So 1 and 42 would work, but again, we're trying to figure out what would give us a negative 23. Now 3 and 14 were positive, which gave us a positive 42. It actually is positive, but since that 23 is negative, we know that both of these will have to be negatives as well. So negative 1 minus 42 gives us negative 43. That is not this negative 23. So that's not going to work. Let's look at another pair. Negative 2 and negative 21. Well, that one seems to work. So in other words, if we split this up, let me get rid of some of this stuff. If we were to split up negative 23, we would have negative 2x minus 21x now, plus the 3. And we'd have 14x squared here. Splitting these on the left there, and again, it doesn't matter if you put the negative 21x here or the negative 2x there. It's not going to matter where you place those. Your answer is going to be the same no matter what. So in this top part, we can factor out a 2x. That gives us a 7x here minus 1. And the negative 21x plus 3, we can factor out a negative 3. Negative 3. So that gives us a 7x minus 1 inside. So that shows right here that they have the same factor that we can factor out of this expression. So we end up with that 7x minus 1. We factor that out. And the first term we have left over 2x, and the second term was a negative 3. And that's it. All right, let's look at this problem here. It's the same idea. If we could factor out any of these numbers, we would, but in this case we can't. 13 itself is prime. So to figure out how we'll split up 13, we need to look at 3 and 4. We'll multiply those. 3 times 4 is 12. Now splitting up 12, again, the easiest one is 1 and 12. And since all of these are positive, these will remain positive. And 1 plus 12 is 13, so that's good. Let's try this. I'm going to switch these just to show you that it doesn't matter where we place the 1 and the 12. Let's look at 3x squared plus 12xy plus 1xy, and you don't have to show the 1, plus 4y squared. And give us some space here. All right. So again, this is grouping, so we're just going to look at those first two terms. We can factor out a 3x, which leaves us with an x in this first term. And in the second term, it's plus 4y. In the second term, we can factor out a y, and this would leave us with an x there, and right here would have a positive 4y. So that's good because we ended up with the same common factor between these two, and yes, that was a positive y. So let's go ahead and factor that out. Factor out an x plus 4y. And then on the inside, we would still have that 3x and the positive y remaining. And that's it. Now you could go through and check this, okay? You could go through and check this just to make sure that your answer is correct. And you would do that by using FOIL or the area models. In other words, you may factor in, or not factor, but distribute the x and then the 4y. And then when you combine like terms, you should end up with the same expression that we started with. All right, there's a couple different ways we can look at 19. For example, if you don't know the squares of binomial stuff, That's fine because this could be rewritten as x squared plus 0x minus 25. So now when we try to split up this negative 25, we'll use 5 and negative 5. And when we split this up, because again, that's because negative 5 plus 5 is 0, which is what we wanted. So you'd have x minus 5 and x plus 5, and that's factored. Now the rest of you may have remembered that x squared minus, well, not x squared, I apologize, a squared minus b squared is the same as a minus b times a plus b, where in this case a is x, b would be 5, the square root of 25, and that's how we would get the same thing, x minus 5, x plus 5. So whichever method you use will work, that's fine. One may be a little bit more work, you prefer one or the other, and on the test I don't care which one you do. All right, let's take a look at this one. Well, some of you like this because you know a squared minus b squared. I've written those too big. That's going to give us a minus b and a plus b. So looking at this one, this would be 6 squared minus the 4 would be 2 squared, and the a squared would just be a squared. So we can square both of those using those laws of exponents. What this tells us is that a here is 6 and b is 2a. So when I look into replacing a and b in this expression, we can do it. So a we know is 6. So we'll replace both a's with 6. And b we know is 2a. Like this. So at this point, some of you may notice that the 6 and the 2 have common factors as well as these ones, okay? So in other words, we can factor out a 2 from this and get 3 minus a. We can factor out 2 from this one and get 3 plus a. And we would end up with a 4. Let's give ourselves some space. 4 times 3 minus a and 3 plus a. And as it turns out, that is the final expression, because you could certainly have factored out a 2 from this point, okay? So make sure you always take a moment to look. As soon as you've done some factoring right there, you could factor out, for example, 6 and 2 are even numbers, so we know we could factor out a 2 at least. Now, some of you may have noticed that from the beginning, though, all right? So let's go ahead and take a look at how that would work. So if I wanted to, I could factor out a 4 from this expression, because 36 is divisible by 4 with a 9, then I'd have that a squared there. Well, we know that 9 is 3 squared, and this is minus a squared. So in other words, we'd have 4 and we'd have 3 minus a and 3 plus a the same way that we just found. Now, notwithstanding all of this, there's still another way we can look at this. So if you can't remember the rules, it's not a big deal. But you have to remember at least this much, okay? So we could rewrite this negative 4a squared plus 0a. This is more of a standard form, plus 36. And since we'll have to do this by grouping, in other words, we'll have to split up the 0, which may sound intuitively it may be counterintuitive, but I'll show you how that works here in a second. So you got to take 36 times a negative 4, which equals a negative 144. And since that's a perfect square, you'd have negative 12 and 12. And we know if we combine those, we'll get 0. So we'd have a negative 12a plus 12a, and the rest remains the same. But since we know we're going to have to do this by grouping, we'll split this up. I'll factor out a negative 4a. And here as well, I'll factor out a 4. I'm sorry, I will not factor out 4, I will factor out 12, which would give me an a plus 3. So factoring out that a plus 3, I'd have negative 4a plus 12 left over. It's a positive 12. But noticing that we can factor out this 4, or negative 4, that would give us, so this would be a plus 3, factoring out that negative 4, which I'm going to put on this side. That's a negative 4. That would give us an a minus 3. Now this one's a little bit different than the way we just did the last one. The fact is we could redistribute that negative if we are committed to making these look the same. And then would have this a plus 3 and times negative a plus 3 and then times 4. So all this does, if I move that 4 to the front, I'd still have that a plus 3. But if I rearrange these, then it will look exactly the same way that last problem did. Would end up with 3 plus a here, and then this other term would be 3 minus a. That's exactly what we had when we did this before. So either one of those work as it turns out. It just depends on how you do this, okay? But the fact is that you get to choose which way works out best for you. And I hope you got this down pretty good. All right, number 21, if we want this in the form a squared minus b squared, then we can see that a is going to be the x plus 2, and b here will be 12. That's because 144 is 12 squared. So that allows us to split that up so that we have x plus 2 plus 12, and then x plus 2 minus 12. Working inside the parentheses would be left with x plus 14 and x minus 10. And that's it. Now if you wanted to expand that x plus 2 squared, you'd end up with the same answer as it turns out. Again, it just depends on if you can memorize this squares of binomial stuff. It's not necessary because, again, you can work from the basics where you would split that up, x plus 2 times x plus 2 minus 144, and then you'd use the FOIL technique or the area models in order to simplify that. But that's the nice thing is if you have more than one technique you can use, you get to choose how you do it, and whichever way works best for you is the way that you should continue to use. All right, 22, these are cubes now. And it may take some work or some work with a calculator to figure out the cube root of 125, but it's 5. So we'd have 5 cubed and we'd have x cubed. So if that rule stuff is working for you, that's great, because what we can do is, well, actually we'll have to use it. So some of you remember it's a, I guess we don't need that parentheses, I apologize, plus b cubed would give us an a plus b, and then would have an a squared minus an ab plus the b squared. Well, we can see clearly that a is going to be the x, or x will be a, and b will be 5. So we're just gonna replace that stuff in there. So we've got all of this, and we'll just fill in the blanks. So this a is x, b is 5, a is x, ab would be 5x, and b is 5 squared. So the last thing we need to do is just change this 5 squared into 25. And that's factored. All right, 23 will work the same way. 64 is 4 cubed, a cubed, so we'll take a deeper look at this, right? So if we split these up, you'd have 4a cubed minus, you could write that as ab cubed, and that's minus there. So since it's minus, our first term will have the subtraction in it, which is a minus b, a squared plus ab, plus b squared. So in this expression, we'll replace the a's and b's accordingly. Like this, okay? So a, in this case, would be 4a. B is an AB. A squared, that'd be 16a squared, because I squared the 4 there. Then would have 4a squared b. And then would have an a squared b squared. All right. Now some of you may have noticed from the beginning we could factor out an a from this factor, and we could also factor out, and looks like we can factor out an a squared from all of these. So we'd have a to the 4th, a cubed in front, 4 minus b, 16 plus 4b plus b squared. Now you could have pulled out that a cubed from the beginning. It's true, but it may not be as instinctive for some of you, so you may have to go through this process and then notice that a can be factored out of both of these terms. So let's go ahead and take a look at what that would be like if we did that from the beginning. So if we factored out an a cubed from these two terms, we'd have a cubed, 64 minus b cubed, and again, this would be 4 cubed minus b cubed, so we end up with a cubed, 4 minus b, this is 4 squared, which is 16, plus 4b plus b squared. And that does it. All right, from 24 to 27, we just need to figure out the values of x that will make this expression or this equation 0. So let's zoom in on 24 here and see if that helps. So the big idea with this, and we covered this in class, is that anything multiplied by 0 will be 0. It doesn't matter what this is. If we multiply it by 0, the answer is 0. But it also works the same way. If this is 0, then it doesn't matter what this is. Multiplied by 0, it's going to be 0. So in other words, what we need is for x plus 13 to equal 0, and also x minus 25 to equal 0. So solving both of these, you'll find that x is negative 13 and x is a positive 25. There's two answers for this. Right here, you can write it as a list if you want. X equals negative 13 and 25, like this. Any one of these will work, but you got to show that there's two answers for both. 25 works the same way, it just looks a little bit different. So this has to equal 0, and this has to equal 0. 2x must equal 0, and 11x minus 9 must equal 0. So let's rewrite those separately. 2x equals 0, and 11x minus 9 equals 0. Well, if we divide by 2 here, it's not going to make a difference. X is still 0. There's our first answer. Looking at this next one, we'll have to add 9 to both sides. So 11x equals 9. And if we divide both sides by 11, we get that x is 9/11. There's our second answer. Now there's a way that we can check these two, just to make sure that our answers are correct. And that is by going back to the original problem and replacing these values with the x values that we found. And we'll make sure that they equal 0. So doing it with 0, let's look at 2x times 11x minus 9. This must equal 0. So if we replace these here as zeros, 2 times 0 is 0. 11 times 0 is 0 minus 9. Well, that's going to give us a negative 9 times 0, which is 0. That checks off. Let's go ahead and look now at 9/11. 9/11. All right. So looking inside this set of parentheses, we'd get the 11s cancel out. You'd have 9 minus 9, which is 0. 2 times 9/11 would give us 18/11. But since it's multiplied by the 0, our answer is 0, and this one checks off as well. So we checked off both of them. Our answer is good. By the way, please check your answers just to make sure that they work. Okay? Sometimes when you do these, you may find that your negative is off. In the next couple problems, you'll see maybe you factored wrong. Something to that effect, okay? So just be careful with this. Checking your answers is a good way to make sure that your answer is right, especially on a test. All right, 26, we got to factor this out, which will help us to see better what the values of y should be. So we're going to take this negative 2, multiply it by 3, the a value, giving us negative 6. Splitting this up, you'd have a 1 and 6, 2 and 3, that's it. Now the problem is this is negative, so if one of these is negative, that's not going to work. See, 2 minus 3 would give us negative 1. Negative 2 plus 3 would give us positive 1. But we need it to be positive 5 so we can split this thing up. And then we can factor this by grouping. Alright, so this means that we got to work with the 1 and 6. So if we look at this, we need that to be a positive 5. So the 6 will need to be positive, the 1 is negative. So we'll split that 5y up into a negative 1y and a positive 6y. This gives us a 3y squared and a minus 2 right here. Splitting these up so that we can factor by grouping, we'll factor out a y here. So we have a 3y minus 1. And it looks like we'll factor out a 2 here, which would give us a 3y minus 1. Factoring that out would get 3y minus 1, and left over would have y plus 2. Now this all equals 0, just like it did in the beginning. So we need 3y minus 1 to equal 0, and y plus 2 also to equal 0. So let's set those equal to 0. 3y minus 1 equals 0, and y plus 2 equals 0. Well, that y plus 2 is pretty easy. Y is negative 2. There's our first answer. Second one, we'll have to add 1 to both sides, giving us 3y equals 1. Well, 3y equals 1. We want to isolate the y, so we'll divide by 3 and get y is 1/3. There's our two answers. Now, how do we know there's two answers? The reason is because the degree of this polynomial is 2, so there should be two answers. Every once in a while you'll get one answer. I don't think that's something you're going to have to worry about until 1050. Alright, 27, this one looks a little bit different, but the concept is the same. The thing is that we will not have to worry about finding factor pairs, and you'll see why here in a second. So we need to move everything to one side so that in the end we're just going to have something equal 0. So in other words, we'll subtract 4x from both sides, and we'll subtract 28 from both sides. So this gives us an x cubed plus 7x squared minus 4x minus 28, like this. Well, factoring by grouping, we would take out an x squared and would have x plus 7. And it looks like we'll take out a 4, so that would give us an x plus 7 as well. So that we end up with an x plus 7 and an x squared minus 4. But notice that this factor right here is one of those squares of polynomial things. So we can factor out that even further. We have x minus 2 and x plus 2. This gives us three answers: negative 7, 2, and negative 2. Done. So again, we have three answers here because the degree of this polynomial is 3. And we have three answers. Now again, I would recommend going back to the original problem and checking your work. You'll plug in negative 7 in for x and see if they are equal, then 2, and then negative 2, and then you should do that all three times and find that they are equal. All right, for number 28, given the statement x to the a over x to the b equals x to the 77th. Find two numbers, a and b, that satisfy the equation. Now, don't worry about this finding other values, okay? So, in other words, this is really just a to the x minus b needs to equal 77, x to the 77. So, a minus b equals 77. You just need any two values that will make that work. Perhaps you wanted to use 80 and 3. Some of you may prefer 77 and 0. Others of you may prefer 90 and 13. That will work. But yes, there are so many of these that you could use for this. All right, well, I think that does it for the practice test. I hope that you found this helpful. If there's any parts of that you don't understand, I recommend going back and replaying the video or finding examples in the book that are like these ones. All right. So good luck studying. Study hard. Yes, the test is on the 22nd, I believe, which is a Monday.